Okay, so this is a probability density function. So if you want to find the expected value, that means in the long run, you expect to get this variable, the value. So there is a mean. So what you should do, you should change the summation sign to what? Summation sign to what? Hello. Nick, Christopher. This summation sign, I must change it to what? You want to find the mean, you have to sum up all the probability of the particular variable times by its value, correct? So summation sign, you must change it to what? Christopher, I thought you all can multitask one faster. You can key in the attendance as well as answering me. Okay, if I want to talk about continuous random variable, I want to find the mean. For discrete, I sum up all the probability, the product of the value of the random variable and its probability, correct? I sum it up. So for continuous variable, I should change the summation sign to you learn chapter 4 or not of your textbook? Do you all learn chapter 4? To integrate, thank you. So the limit will be from A to B, the product of the variable and its probability density function. Are you clear? So that is the formula to find the mean. So all this, you use your graphic calculator. You don't have to do it manually. Clear? Okay, the formula for standard deviation is go in this way. Square root of variance is just without the square root. Sum of xi squared pi, take away the mean squared. Am I right? So to find the standard deviation for a continuous random variable, what we need to do, we also change the summation sign to integration sign. Are you clear? That's all. Because it's a continuous variable. Okay? Then for discrete random variable, it's very hard for us to determine the median. Am I right? When I say the median is M, okay, that means I'm talking about probability of X greater than M, halfway, correct? 50%, am I right? Should be 0.5. So for continuous variable, we can find the median. If the median is equal to M, that means the sum of the probability from A to M, what should the value be? Equal to 0.5. So are you clear? So these three formula you have to bear in mind. There is all these three formula you will use in exercise 8B.1. You better write this one down in your notes. 8B.2. Are you clear? Okay? Can or not? Okay, so now I want to discuss one specific question. That is question 10 in your 8B.2. I want to let you know that the probability density function doesn't mean that I only give you one function. I can give you two functions. So please look at question 10 and we will work on that. 8B.2, question 10. Everyone look at 8B.2, question 10. So what I will do is, if I present this answer in the textbook, in the test or whatsoever, I will tell the examiner that the way we read this, if the value of the variable is between 0 and 0.6, I will use this probability density function, this one. That is how it works. If the value of x is between 0.6 and 0.9, then I have to use this function to count the probability. Are you clear? Other than that, the probability density function is 0. That is called otherwise. Are you clear? Can or not? So I will take out my graphic calculator. Then I will denote this as Y1. I will write down in the question also. And I will write this one down as Y2. So please do that. Straight away key into the calculator. Then you try to present this probability density function, sketch the graph. Okay, please do so. Take out your graphic calculator and do. I'm going to teach you how to present your function. So every time more than 2 functions, you just key in Y1 and Y2. Done. Go to window. Set the domain 0 to 0. 0 is minimum, 0.9 or 1 as a maximum. Then try to do a zoom fit. After you do a zoom fit, you do some adjustment, please, so that you can have a clear picture of the diagram. Okay, so how are we going to transfer? How are we going to transfer? So, okay, every one of us, we will have the graph like that. This is your Y1. Am I right? And your Y2 will go like that. Okay? So now, how am I going to present this? I cannot sketch this graph. If I sketch this graph, is wrong. Okay, so what I need to do is, I need to find the coordinates of this intersection point. Yes? Okay, so what is the intersection point? And in this case, I believe the x happened to be 0.6 also. Am I right? Am I right? Okay, so now look, I'm going to, from here, I'm going to sketch the graph. So my answer for part A, if you sketch this to me, I'll mark you wrong. Okay, so this is your 0. This is your fx. So from here to here, you draw. Here, is it 1.25 or 2.5? Is it 2.5? 2.5, huh? Okay, 2.5, thank you. Okay, 2.5, and here is 0.6. Are you okay? Because this graph, y1, have to stop at 0.6 here. After 0.6, you have to use the y2. So you sketch the y2. And you have to stop at 0.9. Clear? So this will be exactly the one that I want you to sketch. Do you get me? Hello? So this is your y2. Christopher, are you clear? So you cannot do this, huh? You get me? So that is the one. Got it? Sometimes the graph will be a bit different, so you have to judge. Okay, so now we are done with the graph. Okay, now, if I want to do part B, how to check? How to check? So I have to write an integral expression. So now we know that the whole probability density function graph is above the t-axis, correct? So it's always positive. So fx is greater than 0 for x between 0 and 0.9. So no problem. So what is the second criteria? What is the second criteria? Sum of the probability must be equal to 1. So how am I going to show that the sum of the probability? There are two parts. So I have to say integrate from 0 to 0.6 y1 dx plus integrate from 0.6 to 0.9 y2 dx. So I check. Take out your calculator and check. See whether it's equal to 1 or not. Is it equal to 1? Okay, it's equal to 1. So done. You don't have to integrate, huh? You just let the calculator handle all the integration. Unless I incorporate this as an integration question. That will happen in your final, but it will not happen in your S85. Because S85, we try not to incorporate into integration. Understand? Your try exam maybe. Okay, done? Okay, let's go to part C. So when you talk about part C, to find the mean, you have to follow this formula. And now because the probability density function involves two parts, correct? So we have to do it separately with a plus sign. Are you clear? So the mean, you can write this, up to you, or you can write the word mean, your choice. So you have to write. So you write down the integral expression. That is, I integrate from 0 to 0.6 x times what? Y1 or Y2? Y1. Plus integrate from 0.6 to 0.9 x times by y2 dx. So punch into your calculator and get the answer. 0.9. So you got the answer? 5.9. Is it? 5.89 something or what? 0.589. Okay, 0.589. 5899. Okay. Huh? That is the formula leh, young man. Apa cerita ni? This is the formula. To find the mean, it must be the variable times by the probability density function. There. Formula ma? Huh? Yes. Yes. What is your problem? What is your problem? You ask it, I go today, you don't answer me. Okay, can or not? Okay, that is to find the mean. Okay, now to get the median. Okay, listen here carefully. To get the median, okay, before we get the median, we have to check. We have to check. What we need to do is, you see, because the graph go like that, correct? Yep. I have two different functions, correct? So I have to check first. I have to check what is the probability for this one. I have to make some checking first. I have to check. Yeah, I have to check first. I have to find the integral from 0 to 0.6 y1 dx. Okay, can you please check for this case? The first half first. I always check the first half. First part. I don't say first half. I should say first part. The area of the first part. What do you get here? Exactly 0.5. So if you get exactly 0.5, therefore you say that the median is 0.6. Understand? Because the probability is 0.5. Okay, so now I'm going to give you different scenario. Okay, if I check, correct? If when I check, okay, integrate 0 to 0. Okay, for example, I have a graph. Okay, I better draw the graph. If not, after that, you all get confused again. Okay, for example, I have a function like that. Now my probability density function is like this. Yeah, then the other one start from here. This one goes straight up, then the other one go down like that. Okay. So it doesn't mean that it must change at the intersection point, not necessary. Please don't get it wrong. Don't just because of this example. Okay, then lama. And this value is A. Understand? And this one is the B. Okay. N at B, And here is 0. Okay, for example, for example. Okay, this is the x and this is the pfx. This is my y1. And from A onward, I have to use my y2. Okay, so now if I integrate from 0 to a y1 dx, I got less than 0.5. So where is the location of the median now? So that means the median is between A and B, am I right? Because the area is less than, the probability is less than 0.5, less than half, correct? So that means my median is somewhere here. Am I right? Okay. So which means that I integrate from median to B. So the median is under the probability density function of y2, am I right? So y2 dx. What must be the value be? What must be this area be? 0.5. Okay, so this one you can just straight away put into the solver. This is in your E1 and this is your E2. Then you can use your solver and get the median straight away. Hello, are you clear? Do you get me? So every time when you find median, you must do this checking first. Check first. Then you know where is the location of the median. Then you use your solver to help you to solve. Are you clear? Can or not? Yes? Okay. Can I go back to part A again? Can I go back to part A again before I go to the next one? So can I go back? I want to teach you how to use your solver to do certain things. Okay, let's go back to part A again. Okay, now look, in the exam, what I can do is I can even put an unknown here. I put this as K. Then I ask you to find the value of K. So I ask you to find the value of K. So that this is a valid probability density function. So what you need to do is you just need to use your solver. So now everyone try to use your solver. You integrate from 0 to 0.6 y1 dx plus integrate from 0.6 in your solver. This is K, but in your solver you put x, y2 dx. So this one you put into your E1 and the one you put into your E2. Then you use your solver. Then you see whether you can get the value of x as this one in your solver. You put it as x for this one. You put it as x. Then you see whether you can get 0.9 or not. Do you get 0.9? After you key in your solver, you press OK already, correct? Then you have to put alpha, enter. Alpha, enter. So in this case, our solver is very useful. You understand? And also to find the median. Unless I say show by calculus. But in this coming test, I definitely will not do that. But I cannot guarantee you for try exam or for final. You get me? You get or not? You get 0.9 or not? So remember, solver is a very useful tool when you want to find the range of the variable and also the median. Yes. Because my range is from 0 to 0. You see? Okay. So I'm just telling you how useful solver is in this case. So that when you do this correct, you are not disturbed by the algebraic skill. You focus on your meaning of all that. Can or not? Okay, now. Can I move on? Okay, no issue already. Okay, let's move on to, okay. The next one, find the mode shouldn't be a problem, correct? Mode is the highest. The mode is 0.6, am I right? That one I don't have to teach you. Okay, then part D. Okay, if you want to find the variance or the standard deviation, what you need to do? You need to follow the formula as well. All right, so the variance, what is the formula? Is without the square root, okay? Variance, so you integrate, must break into two parts, x squared y1 dx plus integrate 0.6 to 0.9 x squared y2 dx. Take away the mean square. Okay, key into the calculator and get the answer. So the standard deviation will be square root of whatever you get there, then you get the answer. So it's a very relaxing test because calculator handle the difficult part of it. Okay? Let's go to part E. Shall we? Okay, when you talk about part E, you have to be very careful. Okay. You have to know that my possible value of x is from 0 to 0.9. Then the cutoff point is at 0.6. So if between 0 to 0.6, I use my y1. If this one, I use y2. Am I right? So now, if you want to find the probability of x between 0.3 to 0.7. So you see 0.3 is here. So from 0.3 to 0.6, you have to use y1. From 0.6 to 0.7, you have to use y2. So you have to write two separate definite integral. 0.3 to 0.6, I use y1. Plus 0.6 to 0.7, I use y2. So that will be the total probability. Clear? Use your calculator again and get the answer. Are you okay? Yes? Sebastian, what is your answer for part E? You can just put second on, then you off it, then you start all over again. You understand? That is how I do it. Like my computer give me problem, I shut you down. That's it. Instead of going and troubleshoot it, am I right? Like for example, instead of wait for the graph to draw, you don't want the graph, right? You off the whole calculator, then start all over again. You see, that is called, in Chinese, called 爽快.